Alright, welcome back, boys. I haven't touched this YouTube channel since a month ago, but here we are doing binomial expansions, and I'm going to teach you guys a good little method that will save you a bunch of time instead of using whatever this is. So, you can use algebra to do this. So, by letting x equals root 6 and y equals root 3, we can make this expression in terms of x and y. So this just becomes x plus y cubed minus x minus y cubed equals a y. So now this looks so much better than whatever this abomination was. And now what we can do is we could use the formula a cubed plus 3a squared b plus 3ab squared plus b cubed. But here's the case, I'm not going to show you this formula. Instead, I'm going to show you the binomial expansion formula, which makes ensure that you never have to remember this again. So, the formula states that when 3 and at r equals 0, where r is the power of the coefficient, this makes it such that this will be x n minus r times y r times NCR, which is 3CR. So, now we have this. The sigma notation means summation, by the way. Now we have this, and now we can just derive the formula x cubed plus 3a squared plus 3ab squared by just applying the formula. So how did we do this? So we just do sub in r equals 0 at first. So when r equals 0, you just have y to the power 0, which is just 1, times 3C0. So the combination formula 3C0, 3C0 always equals to 1. So this will equal to x cubed for r equals 0. And since we have r equals 0 and the upper limit's 3, we can just keep going. R equals 1, r equals 2, r equals 3. So let's just keep going. X squared y times 3c1. And whenever you have a 1, just remember it's 3. So this will be 3x squared y when r equals 2, 1. And you will notice a pattern. When you see, let this variable be a, and let this variable be b, you can see that a is descending in the power, but y is actually gaining a power. So this will be useful in other preliminary examinations where you have to find this out. So anyways, now that we have this formula and we have a and b ascending, we could just say x cubed plus 3x squared y plus 3x y squared plus y cubed. Alright, so now we have this, and x minus y is essentially the same thing, because this is just this. It's nothing special. This is what it equates to, since you can manipulate inside the brackets. It doesn't really matter. And now that you've got this, you could just say that this is just alternating in power because you just have a negative, right? So all you could just do is, once you've derived this formula, all you need to do is do this. X cubed plus 3x squared y plus 3xy squared plus y cubed. And then don't forget your brackets because this is a multi-expression. X cubed. But remember that in our formula, if we sub in negative y and we put it at the power of 1, we actually get negative. So negative 3x squared y plus 3x y squared minus y cubed. So that is your formula, and now we just expand this. Simple enough. If you watch my calculus videos, you'll be pretty experienced at algebra at this point. So yeah, also a side note, I'm not actually a tutor. I'm just like doing a studying technique where I have to rehearse whatever I'm saying because this makes it click. So if you think I'm a tutor, I'm really not. So yeah, because I got a comment saying that I can do matrices, but I really can't do matrices, so I can do binomial theorem. Anyways, now we have this. We just need to collect like terms, so simple enough. plus 6xy squared. I think that's it. Oh no, that's already cancelled out. Don't do that, because 3xy squared and minus 3xy squared will be cancelled out. This one will be added, this one will be subtracted, so therefore plus 2y cubed. And you can see that this will just equal to a y, because this is what was our expression, and now you can see something sneaky going to happen. Y, just factor out. And then you get a y, but you cancel out the y. So that just leaves you with a, and this is your expression. Plus 2 root 3 squared equals a. In harder problems, you won't get this simple expansion because you either could just remember it, even if you've done polynomials in extension 1 in year 11, you could easily solve this problem. So we're just gonna clear this, but you can see how I got this through a clever algebraic manipulation. Okay, so now we've gone through expansions, let's go through coefficients. And there's this question I was really interested about, and it was finding the coefficient of x cubed in this funky expansion, as you can see. Plus 1 over x to the power of 9. So we don't really know what to do here, but we can use the formula that we just learned, right? So 9r equals 0. Remember to group multi-expressions because then in brackets this is the algebra rules, times 1 over x r, I think, times 9cr. Okay, and now you may be wondering, oh yeah, let's just find x cubed by letting 9 minus r be 3, because, and then we could try argue an expression for 3, but this is not the case, because we have two x variables, so we need to fix this in order by using proper algebraic techniques, using indices rules, if you remember from year 9. So we just do this. 18 minus 2r times x negative r. We are lucky because this would have been times negative 1, so power of r if we had an expression that was different. So lucky for that, and times 9cr. And now you can see something beautiful going to happen. Now that you have 18 minus 2r minus r, you just put it as 8x18 minus 3r. And by finding x cubed, you want 3, right? So you want 18 minus 3r to equal to 3, right? So then therefore negative 3r equals negative 15 and r equals 5. And by finding r, this is usually called the r method because you're always finding the r, that you can find an expression now for x cubed by doing 3, 4 times 9c5. Simple enough. This is your coefficient. And you need a x cubed if you want to have that. So that is the coefficient if you wanted to know. Okay, that's all for today, and I hope you enjoyed. So yeah, I'm pretty excited that I learned this topic because permutations and combinations are my weakest topic, but I finally overcome this and it's been great.